Students, this is a video on the topic tests that we have for you. Now, these topic tests for QA are designed to help you evaluate your preparation topic-wise. So once you complete the basic concepts of a topic, have done a bit of practice, that is when you can take this test to understand your level of readiness of that topic. Once you give the test, that is where this video comes in. So in every video, we analyze the test, give you the solutions, and an idea of what could be a good attempt in terms of time, in terms of level of difficulty. And the best thing is more than 200 topic tests are available on the Bodhee Prep Android app. So the link for the app is in the description below. Download the app and get cracking on these tests to make sure your preparation goes up to full steam. Uh, this video is for the topic HCF LCM, and this is the second test on this topic on the app. Overall analysis for the test will be moderate level of test, 6 questions. Net correct would give you a 95 odd percentile, and the attempt time would go up to 24 minutes because there are questions where we'll be making cases as well. If we look at the questions, question number one says there are 3 watches W1, W2, W3. Once an alarm goes off in W1, it rings for 20 seconds, and then pauses, then starts ringing after 2 minutes. So the pause is for 2 minutes. The respective values for W, so this is W1, W2 and W3. The respective values for W2 are 50 seconds ring and 5 minutes pause. For W3, it is 1 minute ring and 6 minute pause. An alarm is set in each of the 3 watches at 6 a.m. At what time after 6 a.m. will the 3 alarms go off simultaneously for the first time? Once an alarm goes off. So if the alarm is set in all the watches at 6 a.m., they will go off simultaneously at so at 6 a.m. the alarm is set, so all of the alarms ring. One rings for 20 seconds, 2 minutes, then it is paused for 2 minutes. The other will ring for 50 seconds, will be paused for 5 minutes, 1 minute. And so I can say that after 6 a.m., the first alarm will ring after another 20 and 120, 140 seconds. The second watch will ring after 50 seconds. 5 minutes is 5 into 60, 300 seconds, 350 seconds. And the third alarm will ring after 60 seconds here and 360 seconds, 420 seconds. So after every 140 seconds, W will start ringing. After every 350 seconds, W2 will start ringing. And after every 420 seconds, W3 will start ringing. So when will they go off at the same time? The LCM of these 3 numbers, 140, 70 into 2, 350, 70 into 5, 420, 70 into 6. So the LCM will be 70 into 2 into 5. For 6, we already have a 2 into 3. So 5 2s are the 7 3s are 21. After 2100 seconds, to get the time in minutes, we divide by 60. 6 3s are 80, 35. So after 35 minutes, all the alarms will go off simultaneously. Therefore, at 6:35 a.m., all the alarms will go off simultaneously again for the first time. I think understanding the cycle here is important, and therefore I'm saying a moderate level question. But once we identify that, should not take more than 2 minutes because the numbers are pretty simple. The LCM and HCF of 2 numbers A and B are 42 and 14. Because the HCF of the 2 numbers are 14, we can say A as 14 into say X or small a, B as 14 into small b. HCF 14, the small a and small b should be such that A and B are co-prime. The small b and small a are co-prime. LCM is for 420. We know that for 2 numbers, LCM into HCF is equal to the product of the 2 numbers. How many ordered pairs are possible? So A into B, or A into B becomes 14A into 14B, can be written as LCM. 420 into 14. 14, 14 cancel. 14 3s are 42. So A into B is 30. 3 and 0. So if you look at A and B, A and B can be 1 and 30. 2 and 15, 3 and 10, 4, 30 is not possible, 5 and 6, 6 and 5 because we're looking at ordered pairs, so we'll reverse the values as well. So these are the cases possible. 30 essentially is 2 into 3 into 5. So this will have 8 factors. Every factor can take a value of A, and correspondingly there will be a value of B. As we can see, in no case will the two values have any common factor because all the powers are 1. So all these 8 cases, 1, 2, 3, 4, 5, 6, 7, 8 will give us answers. Ordered pairs could be 14 into 1, 14 into 30, 14 into 2, 14 into 15, 14 into 3, 14 into B, and so on. Hence, 8 solutions are possible, and that becomes the answer. In terms of level of difficulty, I would say a moderate level of difficulty question because cases are to be counted and the ordered and unordered pair can create a bit of confusion, but not more than 2.5 minutes to solve the question. A minus B is equal to B minus C is equal to 8. LCM of ABC is a 4-digit number. What is the maximum possible value of A? Now A minus B is 8, so A minus B 8 means A is equal to B plus 8. And B minus C is equal to 8 means B is equal to C plus 8. So we can say that the three numbers, now if I substitute B, the value of B here, I can write A is equal to C plus 8 plus 8, which is C plus 16. So the three numbers are C plus 16, C plus 8, and C. The difference here is 8. The difference here is 8. We know that the product of the three numbers has to be, for three numbers, we write HCF square into LCM. LCM is a 4-digit number. We want to multiply, maximize C. To maximize C, we will also want to maximize the HCF. And therefore, the maximum HCF possible is 8. Because the difference in these two cases is 8. So if we take the HCF as 8, we can say C plus 6 into C plus 8 into C is 8 square into the LCM. Also, C can be written as a number which is say 8x. C plus 8 will be 8 into x plus 1. C plus 16 will be 8 into x plus 2. These x plus 1 and x plus 2 will be consecutive numbers. Cancelling out 8 square, we get x into x plus 1 into x plus 2 has to be a 4-digit number upon 8. Now, the largest 4-digit number that is divisible by 8 will be 8. The last 3 digits have to be divisible by 8. Therefore, 92, 992. And therefore, x into x plus 1 into x plus 2 has to be less than equal to 992 upon 8, which will be 1, 2, 4, 9. Three numbers, consecutive numbers which have a product of a maximum 1, 2, 4, 9. If you put x as 10, 10 into 11 into 12. This is 1320, so not possible. If you put x as 9, 9 into 10 into 11. This is 990, which is less than equal to 1249. And therefore, the value of x is 9. So the smallest number will be 8 into 9, 72. Next number will be 72 plus 10, 72 plus 8, which is 80. And the third number will be 80 plus 8, which is 88. The three values of A, B, C, A being the largest, will be 88, 80, and 72. Hence, the value of A, maximum possible value of A, would be 88. And for me, that becomes the answer. Again, I would say this is a difficult question because figuring out the first line could be a little challenging, and taking the starting values could be difficult, and therefore 2.5 to 3 minutes, but a difficult question overall. For two positive integers A and B, define the function h of A and B as the greatest common factor. So basically, h of A and B gives us the HCF of two numbers. Let A be a set of n positive integers, GA. The GCF of the elements of set A is computed by repeatedly using the function h. So basically from A, we will take two numbers at a time and find the HCF. The minimum number of times H is required to compute G. Okay. So let us take A as a set of four numbers to start with. Say 2, 12, 38, and 50. So first we use H on the two numbers 2 and 12, we get HCF as 2. Then we use HCF on the next two numbers, that is 38 and 50. We get HCF as 2 again. Again we put H, so we find out the HCF of the next two numbers, we get the HCF as 2. So the function H has been used 3 times for n numbers, which is n minus 1. The idea being every time one number will be eliminated. This is the same as a tournament that we have, the knockout tournament, where two players play at a time. How many matches will we play to get the winner? The answer is n minus 1. So by that similar logic, we get the answer as n minus 1. I think a moderate level of difficulty question, also if we figure out what is happening, it is not difficult to solve. And I think a good idea always is simply take values and solve from there. Not more than 90 seconds to get the answer. The integers 34041, 32506 when divided by a 3-digit integer leave the same remainder. So the number that leaves the same remainder when it divides the two numbers is the difference or a factor thereof. So we take the difference of 34041, sorry, 32506. This will be 35 1535. 1535 is a 4-digit number, and therefore 1535 and any factor of 1535 will give the same number when it divides these numbers. So we factorize 1535 divided by 5 is 307. 307 is prime. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 13, 26, 13, 15, 17, 17, 137, 47. 17, 137, 17, 719, 36. Not happening. 19. 19 square is beyond 307. And therefore, 307 is prime. So 1535 and its factors 307 and 5. 1 divides everything. These are four numbers which, when they divide these two numbers, will leave the same remainder. Out of these, the only 3-digit numbers is 307. That becomes my answer. I think this is a straightforward method that is to be applied. So 90 seconds, easy question should be done in the sum of the LCM and HCF of two natural numbers A and B is 57. What is the minimum value of A plus B? A and B are not co-prime. Suppose the HCF of the two numbers is H. So we can say A is equal to say H into X, B is equal to H into Y. These can be the two numbers such that X and Y are co-prime, but H is not equal to 1 because A and B are not co-prime. The LCM therefore of these two numbers will be H, which is common, into X into Y. The sum of the LCM and HCF, so H into X into Y plus H is given as 57. LCM of and the HCF of two numbers. This means H into XY plus 1 is equal to 57. Now if we look at 57, 57 is nothing but 19 into 3. So we can write H into XY plus 1 is equal to 57 into 1, or H into XY plus 1 is equal to 19 into 3, or we can write H into XY plus 1 is equal to 3 into 19, or we can write H into XY plus 1 is equal to 1 into 57. 57 can be expressed as a product of two numbers in 4 ways because it has 4 factors. Now in this case, if H is equal to 57, XY is equal to 1, XY plus 1 is equal to 1, XY will be 0. That obviously cannot be the case. In this case, if H is equal to 19, XY plus 1 is equal to 3. This means XY is equal to 2. The only possibility is that X is equal to 2, Y is equal to 1. So the two numbers become 19 into 2 and 19 into 1, which is 38 and 19. In the third case, if H is equal to 3, XY is equal to XY plus 1 is equal to 19. So xy is equal to 18. The possible solutions for xy here is 1, 18, 2, 9, 3, 6, 18. 9 to the 18, 9 to the 18, 3, 6, 6, 4, 6, 3. Again, the solutions will reverse. So these are the four possibilities. Clearly, the out of these, 3, 6 will not be considered because xy had to be co-prime. And therefore, the lower sum for x plus y will be in case of 2 and 9. So we get the two numbers as 3 into 2 and 3 into 9, which is 6 and 27. Third case, x is equal to 1, that is not possible as per our given condition, and therefore the lowest sum happens in this case when x and y are values 2 and 9, and the sum will be 6 plus 27, which is 33, option A. I think a moderate to difficult level of question because multiple cases have to be formed, and the attempt time will also go up to 2.5 minutes, I think. HCF of two numbers is 12, the product is 3114. The two numbers can be written as 12A and 12B such that A and B are co-prime. Therefore, the equation that we get is 12A into 12B is equal to the product of the two numbers is 31104. So we divide 31104 by 12 and 12. 31104. We are dividing, sorry. 12 2s are 24 minus 7 1. 12 5s are 60 minus 110. 12 9s are 108 minus 24. 12 2s are 24. So this gives me 2592. Again divided by 12. 12 2s are 24. 19. 12 1s are 12. 726. A and B is equal to 216. How many such numbers are possible? If we look at 216, 216 is nothing but 6 cube. 216, or this can be written as 2 cube into 3 cube. The number of factors here will be, are these ordered pairs? No, they are not. The number of factors here will be 9, but again, the factors should be such that they are co-prime, and therefore only two cases are possible. Either one comes here, and for B we have the entire number, or 2 comes here and 3 comes on the other side. Anything else will be a case where 2 or 3 gets distributed on both A and B, and therefore these two cases will give us the answer. If that is not clear outrightly, we can always write the values and check. There will be 16 factors here, 3 plus 1 into 3 plus 1, and therefore 8 ways of writing 216 as a product of two numbers. 1, 2, 3, 4, 6, 8, 9, 1, 2, 3, 4, 5, 6, 7, and 12. 4, 3 are 12. 12 into 18, 9 into 24, 8 into 27, 3 to the 6 into 36, 4 into 27 into 54, 3 into 8 9 are 72, 2 into 27 into 108, and 216. As you can see, these two are co-prime, these two are not. 3 and 72 are not. 4 and 54 are not. 636 not co-prime. 8 and 27 are co-prime. 9 and 24 are not. 12 and 18 are not. So two cases possible. Since we are not looking for ordered pairs, we don't have to look at the reverse. Hence 2. Again, since we have done such kind of questions, therefore, I am saying moderate, but the attempt time could be high depending on the comfort with this question. I am saying 2.5 minutes should be correct, but even if we are getting it in about 3.5 minutes, that is all right, because at least it is a short question that we are getting. A rectangular floor is fully covered with square tiles of identical size. The tiles on the edge are white. The tiles on the interior are red. The number of white tiles is the same as the number of red tiles. The possible value of the number of tiles along one edge. Now, if we look at the rectangular floor, and we put tiles on the edges. So here we have tiles on the edges. These are square tiles, so one of the tiles will be here at the edge, and so on. Now, assuming that there are A tiles inside here and B tiles inside here, so we can say that the number of red tiles is simply A into B. White tiles are on the outside. White tiles will be A, B, B, and then these four on the extremes. So white tiles will be 2A plus 2B plus 4. So we, according to the question, twice of A plus twice of B plus 4 is equal to AB. We can say twice of B plus 4 is equal to AB minus 2A, which means 2 into B plus 2 is equal to A into B minus 2, which means A is equal to 2 into B plus 2 upon B minus 2. Now, if we put values of B and we will get values of A, clearly B has to be more than 2. Otherwise, A would be negative or not possible. So, when B is 3, A will be 3 minus 2 is 1, 3 plus 2 is 5 into 2, 10. When B is 4, 4 2s are 6, 6 2s are 12 upon 2. A will be 6. When B is 5, this will not be a integer, 7 by 3. When B is 6, 6 plus 2, 8 upon 4, 8, 8, 16. When B is 6, A will be 4. The numbers reverse. 7 will be 9 by 5, not an integer. 8, 10 upon 6, not an integer. 20 upon 6, not an integer. 8, 9, 10, 9. 11 upon 7, not an integer. 10. When B is 10, 10 plus 2, 12 into 24. 24 upon 8, 3. So these are the 4 solutions that we will get. When will this be equal? 2B plus 2 is equal to B minus 2. B is equal to minus 4. So this is not happen. Can never be 1. For B greater than 10, we'll get for 11, 13 upon 9, 26 upon 9, 13 upon 9 into 2 for B11. For B12, 2 into 14 upon 10, 2 into 15 upon 11. As you can see, the value will keep on decreasing. The value will keep on decreasing. 1.4, 1.4. But after this point, we'll not get a solution because the reverse solutions have been had. Now, in this case, what is the number of possible values, number of tiles along the side, one of the edge? If B is 3 along this edge, the number of tiles will be B plus 3 plus 2, 2 on the corners, which is 5. And here it will be 10 plus 2, which is 12. Here it will be 4 plus 2, 6. 6 plus 2, 8. 6 plus 2, 8. 4 plus 2, 6. 10 plus 2, 12. 3 plus 2, 5. So from the options, the number of the number of tiles on the edge could be 12, 8, 6, 5. The only option present is 12. That becomes the answer. In terms of level of difficulty, I'd say moderate to difficult level of question because we will have to find all the possible solutions. And therefore, towards difficult, easily 2.5, 3 minutes to solve the question. A group of students is to be divided into some rows such that all the rows have equal number of students. When 7 students are put in each row, 3 are left. Divisor 7, remainder 3. When students are put in, when 8 students are put in each row, divisor 8, 5 are left, remainder 5. When 9 are put, divisor 9, remainder 7. If 12 students are put in each row, then how many students will be left? As we can see, the remainders are different and the difference is also different. And therefore, we'll do this case by case. If the number of students is n and it is given that n by 7 leads to a remainder of 3. What are the possible values of n? It could be 3. We'll get the first number, check for the second one, and so on. So 3, keep adding 7 to this, 10, 17, 24, 31, 36, 41, 48 and so on. 3, 10, 24, 31, 38, sorry, 45, adding 7. And we'll write 8 such numbers to be sure that we have a value. 1, 2, 3, 4, 5, 6, 7. This is 45, 52. Now this is okay. Now check each number for 8 because n divided by 8 should give a remainder of 5. 3 divided by 8 is a remainder of 3. Here we have a remainder of 2, 8 to the 16, remainder of 1. The remainder is decreasing by 1. So 24 is a remainder of 0, 7, 6, 5. We get the remainder. So 45 satisfies the first two conditions. The further number that satisfies this condition will be 45 plus LCM of 7 and 8, which is 56. So 45 plus n times of 56 will be the numbers. So what will be the number satisfying the first condition? 45, and we start adding 56 to it. 45 plus 56 will be 101. 101 plus 56 will be 157. 157 plus 56 will be 213. 213 plus 56 will be 269. 1, 2, 3, 4, 5. 269 plus 56 will be 325. 325 plus 56 will be 381. 381 plus 56 will be 437. 1, 2, 3, 4, 5, 6, 7, 8. 437 plus 56 will be 493. We've written 9 numbers because the next divisor is 9. We could have also gotten this value by looking at the pattern. So now what we do is, if this is n, we divide n by 9 to get the remainder. We're looking for 7. 45 by 9 is a remainder of 0. 101 is 1 plus 1, 2, so remainder of 2. 157 is a remainder of 7 plus 5, 12 plus 1, 13, remainder of 4. As you can see, since the remainder is increasing by 2, without writing these numbers also we could have written the next remainder will be 6, then 8, then 10. 10 divided by 9 means a remainder of 1, plus 2, 3, plus 3, 5, 2 plus 2, 1 plus 2, 3, 3 plus 2, 5, 5 plus 2, 7. So this is where we are reaching. So even if we had not written all of these numbers, we could have simply said that 45 is the first number. Then we have to add 56, 1, 2, 3, 4, 5, 6, 7, 8 times. 56 into 8 is 56 into 8 is 448 plus 45 will give us 493. Hence the number of students is 493. Or further numbers that satisfy this condition will be LCM of 7, 8 and 9, which will be 7 into 8 into 9, which will be 7 into 4 3s are 12 into 4 2 and 3 6. 17%. So 493 plus, I'm writing this as or 40, 72 into 9, we can 72 into 7, we can calculate as 504. So plus 504n. This is the number of students that are there. If they are divided in groups of 12, 493 plus 504n when divided by 12, clearly 504 is divisible by 12. So here we will have no remainder. We'll have a remainder because of 493. 493 is nothing but 492 plus 1. 492 is divisible by 12. 4 and 3, and therefore the number of students remaining will be 1. Option A. I wrote all the possible numbers by adding the LCM, but looking at the pattern of the remainders is a faster way to solve. And in that case, you will take about 2.5 minutes to solve. But I think overall level of difficulty of this question clearly is high or a difficult question. How many ordered pairs A and B? How many ordered pairs A and B of natural number is the LCM of A and B this? Okay. So the LCM of A and B required is 2 raised to power 3 into 5 raised to power 7 into 11 raised to power 13. Now if we look at A and B, the power of 2. If the power of 2 in A is 3, the power of A here could be 2 raised to power 0, 1 or 2 or 3 for that matter will not, the LCM will still be the higher power out of the two. If the power of 2 is 3 in B, the power of A could be 3 or anything less than 3. So these are the cases that we will get. 1, 2, 3, 4, 5, 6, 7. So basically 2 into 3 plus 1. For powers of 5, a similar thing will happen. If the power of 5 is 7 in A, B could be anything from 0 to 7. So 8 cases there. And if B is 7, then A could be anything from 6 to 0 because 7 cases already been counted. So 2 into 7 plus 1. This is powers of 2, this is powers of 5. For powers of 3, 11, similarly 2 into 13 plus 1. The total number of cases will be 2, 3, 6, 7 into 7 to the 14 plus 1, 15 into 3 to the 26 plus 1, 27. Powers of 2 have to happen, powers of 3 have, powers of 5 have to happen, and powers of 11 have to happen. So this becomes 7 into 15 into 27, 15 into 27 uh, into 7. 27 into 15 will be 27 into 10 plus 27 into 5, which will be 405. 405 into 7 will be 2835. 7 4 are 28, 7 5 is 35. So the required answer becomes 2835. There is a basic concept of counting number of factors or PNC also involved here. So I'd say moderate to difficult question, 2.5 to 3 minutes easily to solve. So if you look at the overall, as I said, moderate level of difficulty, but the attempt would be around 6 questions and this test will take time. The 6 questions that I would choose here are 1, 2, 5, 7, 8, 10. Which are these questions? I would be doing this because we've done such questions earlier. This I thought was not a very difficult question because the number was small. This I think was a good question where you had to imagine cases and then work from there. This again may not strike in the exam. This is a straightforward question, easiest of the lot. This again, we have to make cases, find solutions, could be left in the exam. This I think was easy because 216 was breakable into numbers. And again, even if it takes time, at least we are sure what we are doing and we will get the answer. So attempting in the exam. This again, solutions had to be found out for both A and B. One equation, two variables could be left in the exam. 9. This was a lengthy question. So out of 8 and 9, you could choose one. I would have done 10 because have done factor theory as well. So with the knowledge of both the topics, this could be attempted. So 1, 2, 5, 7, 8, 10. Out of 8, if you think you could also substitute and put in 9 here, but those will be my 6 questions.